Back in 2008, the UK government made some commitments to reduce its carbon footprint, and they signed them into law, so we have legally binding obligations as a nation to deliver a 80% carbon reduction by 2050. And part of the work that we're doing in Electricity North West is to try and facilitate that transition to a low carbon economy. Now, the big impact on us as distribution network operators is customers that connect to our network will see over the next 35 to 45 years changes in the way they consume fossil fuels.
The generation mix is changing from one where it's fairly flexible and controllable and predictable with lots of coal and gas generation to one where we've got lots more renewable generation, which just by its nature is less predictable. There's a bit less control there, and some of it's less flexible. So we're going to need to have tools and techniques that help us manage that changing, that supply that's got different characteristics. Also thinking about the electricity demand side. So in order to meet those carbon reduction targets, we're also likely to need to decarbonise on that side, so potentially with lower carbon forms of heating for our homes and businesses, so with heat pumps, and also potentially with electric vehicles to replace petrol and diesel.
Our approach in Electricity North West, or our innovation strategy approach in Electricity North West, is to try and maximise the use of the existing assets that we have. So CLASS, as a project, has a small additional amount of smart technology that's added to our network, which potentially will deliver massive benefits, reduce or defer the amount of reinforcement that we may need to do on our network.
CLASS stands for Customer Load Active System Services, and it's about understanding the relationship between voltage and demand.
The idea behind CLASS is that you can alter voltage on the system, that you can alter the demand, which means you can have local changes, which may mean that the substation doesn't need to have its assets enhanced or renewed, saving customers money, or it can mean that you're there to help the national grid balance supply and demand. On the CLASS project, we're using 60 primary substations to achieve the aims of the project, and that equates to around about 470,000 customers across the entire patch.
The equipment we've installed is a dashboard which is integrated with the control room management system. It's a standalone system that's fully integrated.
As part of the CLASS project, we use a device that we refer to as the ASC, which stands for Autonomous Substation Controller. The idea of this is that the device is literally a box on the wall, and its job is to take commands from our remote control system, the way we normally operate the network from our control centre, and it's designed to change values on the tap change control relays, which change the voltage to the customers on the system.
In the E&W network, there are a lot of primary transformers, and from the order that is given via the control system here, we're able to get these transformers to change their tap position. In so doing, they give a certain short-term demand relief, which is very useful to the grid.
Basically, we have two links, connection to the dashboard. We have the main link from one of the control centers to Electricity North West Control Center, and then we have the backup link to another of the control centers in case one of the links should fail. And then we have the dashboard, which have two screens. You have the frequency screen and the voltage screen. And from there, we can actually issue instructions to E&W and back.
The Envoy unit is required because we need a fast and reliable way to get data back from the primary substation sites in the CLASS trial in order that the information from those transducers can be analysed by people on the CLASS project and also by our partners, University of Manchester. And the reason they need this data is to confirm some hypotheses which are in the CLASS project.
As part of Trial 1, we will initiate a change in tap position from the control room. This will result in a change of voltage out on site and hopefully a change in demand. This change in demand will be recorded by advanced monitoring equipment, and we will pass this data on to the University of Manchester to analyse.
Whenever we're carrying out CLASS techniques at the primary level, we monitor at an LV level to ensure that there's no adverse effects felt by the customer and make sure our voltage stays within statutory limits.
I moderated the group discussions that we held at each stage of the class research project, which happened over a 4-month period from October 2013 through to January 2014.
I started off with leaflets and questionnaires. There was also a video, and we all gave our opinion as to the format of the leaflet, what we thought caught our eye, what we didn't like, what we did like.
We all gave our opinions of the colours, the things that were boldest, the things that were first and last, the things that needed to be mentioned the most, and the beginning to the end. I think it was a much different leaflet at the end.